Hi, I'm Kyle Cordes at Oasis Digital. Here's my contact info. And today I'm going to walk you through a conversion we did here. A team of us converted the MobX open source project to build with Bazel. So to clarify, we do not recommend using Bazel to build MobX. We're doing this solely as an example, as a way of offering explanation to sort of see how that conversion process works. I think it's important on things like this to share credit where it's due. So these are some other people on our team here who were involved either coding or reviewing the work you're going to see today. For the agenda, I'm going to tell you what MobX is. I'm going to show you how its build works, or at least explain how its build process works. And then I'm going to show you how it works after our conversion to Bazel to sort of explain the differences and similarities. Okay, let's go to code. And just I'll show this again when I get back. If you're interested, we do training and consulting and on many full stack topics, now including Bazel. Okay, so to the code. So MobX is somewhat popular in the React world, although it's not React specific. It is a state management system. So for example, if you're familiar with Redux, this is a very different way to achieve the same state management goals that you would achieve with Redux if you're in React, or with NGRX Store if you were in Angular. You can sort of think of it as being maybe like a different take also on some of the same ideas that are in RxJS. But we don't really care what it does for the purpose of this build work, so we don't need to look anymore about it. So if you're familiar with MobX, that's great, but you don't have to be to understand the rest of what I'm going to show here. Okay, so this is the source code for the MobX project. Just so you can see the URL, you know exactly what we're looking at. And I'm going to look at this code in an IDE in a moment. If you want to look at that code after our work, this is our fork. You can see the URL in here, so on, to see our fork where we've made this conversion. And then just to clarify, I'm going to clear this repeatedly again, we're doing this for explanatory reasons. This is not intended to be PR'd or merged or anything else. The MobX project is perfectly well suited to build with its pure JavaScript build machinery that it uses right now. Bazel is a great choice for huge, scalable, difficult builds, not a great choice for small, relatively straightforward things like MobX. Okay, so I am on, let me see, make sure I'm in the right place here. So this is the code before any work has been done. So MobX is a JavaScript project, so the starting point for all things is typically the package.json file. Its build is orchestrated with a combination of NPM package scripts, which you can see some of here, and JavaScript files that actually operate the build, primarily this Build.js file. So they define two types of build. They have a quick build, which all that does is the TypeScript compilation, I guess, to spot any TypeScript errors. And then they have a small build, and I think the idea there is to produce a smaller build output. That might be why it's named small build. But this is the one that actually gets operated if you're going to say publish a new version of MobX. So what they call small build is the real build. We aimed for the scope of our conversion to be targeted primarily at this essential build, and then need to spot the right test. The Jest tests, because those are the primary unit tests here, and more importantly, what they call the Webpack tests. Those are tests that verify that the NPM package build output from this process can in fact be consumed in a JavaScript project downstream. So that's the scope we aim for. There are some other parts in here. For example, they have a documentation website that we saw a moment ago. Here they have some package scripts that run that. That's built with a tool called Docusaurus, and that would be its own interesting, different problem to convert that to be done with Bazel. And it seems sort of out of scope for the core conversion. We also, let me see here. I don't think we converted the lint target because that's typically is something people mostly look at in their IDE. Although there's certainly no obstacle to running the lint as part of the build. I don't think we did that. Okay, so there's a bunch of package script here that sort of orchestrates what parts flow together to form the build, but most of the work actually happens right here in this Build.js script. Now, This is a reasonably representative example of how some JavaScript projects build. So it's relatively ad hoc. It's just a JavaScript file. It doesn't use any of the various JavaScript build machinery. For example, there's a pretty decent thing called Broccoli. Never seemed to get a lot of momentum, but Broccoli is a great take on how to build. There's the very popular in the old days Grunt and then Gulp. And of course, there are many other ways to build your stuff with JavaScript. This does not use those. This just uses a JavaScript file. Like most JavaScript projects, its kind of fundamental view of the world is that when you build, you mutate the contents of the project directory. So they've made some attempt to separate build output. So for example, you don't see a lib directory here, but some of the build output lands in a directory called lib, but other build output lands in these other build output directories. It's kind of an ongoing challenge when you go to kind of impose a tight order on a JavaScript build process that just much of the NPM package community doesn't really have a view of the world where you have like an unchanged source directory and then a totally separate output directory. It's much more common to see inputs and outputs interleaved either directory by directory or even in some cases file by file. So with that context, I'll explain a little more about what this build script does this old way, and then we'll move on to seeing what we did. Okay, so in this build script, it has no notion of incrementality. So every time you run it, it simply gets rid of any previous build, and then all of this code is to run the TypeScript compiler, and so actually, you know what? I'm going to make that's a little much here before I get too much into the code. I think this will be, yeah. We'll call this good enough. So hopefully you can read this size. Okay, so it runs the TypeScript compiler. Now they're choosing to configure the TypeScript compiler by having a static tsconfig file, and then based on some parameters, they override that configuration, and then they will call the TypeScript compiler here programmatically. This seems like a pretty low-level thing to do, but this was probably the most straightforward programmatic way to configure the exact set of TypeScript options they want. It would probably be a modest improvement to remove some of this code and instead just have more than one tsconfig file and have your build process use those different tsconfig files. That would be a little bit more declarative, but this works, and there's nothing inherently wrong with this approach. Okay. Right here, we have some error checking whether the build actually happened, and then down here we have the top level of the build, right? So we call this async function, and we basically build the TypeScript twice. So we use this function up here to do the TypeScript build. It's quite a bit of code, and then it's not super clear to me, but I fear that this might be a bit asynchronous in some cases. I'm not 100% sure that this is a legit thing to do. I just haven't studied the TypeScript compiler API enough to know whether it's always okay to check that output immediately after. Okay, I'll have to pause my recording for just a moment here. About that pause. Okay, we'll come back to this function. I was going to show the high level here, the top level code. Okay, so we run TypeScript a couple of different ways, and this is intended to be synchronous code. Then we come up with a build directory, and then we loop through and generate, I guess, 6 different bundles. So this is kind of nice. They've abstracted out how to generate the bundles. Sometimes they do it off their ES5 build, sometimes off of 6, and then they target different file names that. So they do a reasonable job of encoding the type of build. Like I probably would have named this, like that, if I was doing it. But you could read through the detail. The details don't matter too much. Just to know that the TypeScript is compiled 2 different ways, and then there are 6 different build outputs created. And then there's a separate script, one that we won't do as much with, but they have their own publish script. Fundamentally, their publish script will call npm publish, which calls npm package behind the scenes. Okay, so that's a pretty high-level explanation. There was one bit in here I thought might have been worthy of explanation, though. Let me see if I can spot when they call rollup. Right, so this is the code that generates a bundle. It does this by calling rollup. They call Terser inside of rollup. And this is a very, very common thing to do in the JavaScript world. You sort of have this order of n squared problem. That may be why there are so many NPM packages out there. But in the JavaScript world, it's reasonably idiomatic that if I have a tool and I have another tool and they're going to be somehow used together, then there will probably be yet another tool that takes one and plugs it into the other. And so, for example, if I'm using Rollup and I want to apply Terser to the output, the most common way to do that in a JavaScript build process is to use the Rollup Terser plugin to embed the execution of Terser inside the execution of Rollup. We have a different way of thinking about that in the Bazel world that avoids needing this order of n number of different tools. But this is a reasonably common and idiomatic thing in JavaScript. Okay, so let me just I'll go back to my slides for just a minute and talk. So now we're going to switch to the Bazel version of most of that. So the idea is to take that existing build and then purely for kind of explanatory purposes here, maybe future teaching purposes, to convert that and build most of those same things or the important parts of that same thing using Bazel. So let's go back into the code and see how that works. Okay, so I'm on master, and that master corresponds to what you can see right here as the current master. But just in case I make some further tweaks after this video, if you go in here to tags and you click in here, I made a tag called video 2019. So if you go in and click on that, you can get the exact version of the code that I am looking at in this screen video. Okay, so we have a Bazel program. Typically, the place you start trying to understand Bazel is with a Bazel version file, so you know what version of Bazel is intended to be used. I'm using version 2.0. It just shipped a few days ago, but Bazel is using semantic versioning. So 2.0 is really not very different from 1.0. They changed a couple of incompatible flag defaults, but for most code, including what we're doing right here, it wouldn't matter if I was using 1.2.1 or 1.2 or probably even 1.0. So just be aware it's one of those semantic versioning things where you should maybe be less scared about going to the next major version than you would on a project that had a different versioning scheme. Okay, so this is my converted code. I have removed the old Build.js file because I'm going to do something else instead. That something is I'm going to start with Bazel version 2. Now I need to go gather up my tools to use with Bazel, and that is always done in a workspace file with Bazel. So I'm just going to walk through this briefly. If you are deeply familiar with Bazel, you could probably skip forward 2 minutes. But just in case you're not, let's explain what this means. So when you're setting up a workspace, you don't have to give it a name, but I chose to. But I also have set up this managed directory capability so that when I have Bazel handle my node package fetching, it can make that available here for my IDE to access. And that's a nice capability. I think that was added somewhere around 1.0. With Bazel, there are some built-ins. Some of those built-ins are still always available by default, like the operation load, but many of the built-ins are actually sitting inside a kind of library toolkit built into Bazel. One of those is the ability to retrieve code via HTTP. So we go make that available. So now we have the HTTP archive rule available. So we're going to use that to go fetch the rules Node.js. So this is the Bazel support for JavaScript. It probably should be named rules JavaScript, maybe most ideally, because it's actually not specific to Node. Rules Node.js contains both the Node support, but it also contains a lot of support for browser-side JavaScript. And it looks like I'm on version 1.0.0 of that. I don't know if that's quite 100% up to date. If you went and you searched for rules Node.js, you could go find out. Okay, I'm going to pause for a moment, just verify that that's right. Verified that this 1.0.0, this is the current version as of 3 days ago as I record this. So it just went 1.0 stable. That means they'll be very careful about API changes. There will not be any breaking API changes until 2.x. I would expect there'll probably continue to be reasonably rapid development. Rules Node.js has been evolving and improving quickly over the last 6+ months, and I imagine it will likely continue to do so. Next, from these rules Node.js, we grab the ability to set up Node and Node packages. So we bring in Node again. So this is not relying on a version of Node I happen to have on my machine. This is a Bazel managed Node installation. And then it's not relying on me running Yarn. Bazel will run Yarn, and it will manage the resulting files, and then based on this mechanism, it will expose those to me so that I can use those same files in my, IDE. When you've done this, when you've brought in when you've used the Bazel rules Node.js yarn install or npm install rule to bring in npm packages, sometimes there'll be further Bazel code, Bazel rules inside there. So let's take a quick look here. Again, this is my edited version. So sure enough, there are several Bazel rule sets being brought in via NPM. Now, some people find this very surprising at first. It's not yet clear to me what all idioms will emerge as like the best way to do this, but at the moment, this seems to be the way to do this in Bazel, is to package up Bazel support for libraries in a certain ecosystem in a way that they can be brought in the same way as the other tools in that ecosystem. That seems to be emerging as at least one reasonable way to do it. So when that happens, there's going to be a bunch of dependencies that need to be brought in for those things, and that machinery is right here. TypeScript specifically has some additional setup, and so that is performed here. It seems to me in some future version it may be possible to have that happen as part of this operation, but at the moment it does not. You have to do this. Next, skylib. I really thought I had removed the need for skylib. Let me go double check. I do use skylib in one place, so I'll leave it. So the curious part about skylib is its name. So today's Bazel has emerged from or descended from an internal Google tool called Blaze. Blaze had an extension language, configuration language called Skylark. Well, when the time came to send those out into the world, there was apparently something wrong with the names Blaze and Skylark. Taking a wild guess, I don't know if they ever said, but my wild guess is there was a trademark conflict, that somebody else had a product that was a plausible trademark conflict with those names. So the external tools became Bazel instead of Blaze and Starlark instead of Skylark. Well, Skylib was the sort of standard library or common library for Skylark. That has not been renamed, and so I kind of wonder if this will end up being renamed Starlib in the future. But for the moment, just Bazel Skylib, this is a set of common things you're likely to need as you use Starlark. Next, we do some Webpack testing, and we wanted to do Webpack testing in sort of isolated NPM package sandboxes with 2 different versions of Webpack. So this is basically echoing something that was done in the old build and the build that you could tour in the MobX source code. They run some tests with Webpack versions 1 and 2. Well, those are both quite old now. And so to echo that same kind of complexity, we have built with Webpack versions 3 and 4. But we want to make sure that with just Webpack and the package we've produced for MobX, you can get a program up and running. And so we need a separate workspace. We need like an isolated workspace so that we have absolute confidence we're not accidentally relying on that other workspace. And to do that, we've just used this yarn install rule again. And we'll go over this in more detail when we get back to how those tests work. Okay, so if you just ignore everything from line 46 down, this is everything we need to bring in this basic tool set so that we can build JavaScript and TypeScript code with Bazel. Okay, So this is our main build Bazel file. So it's the one at the root of the project. So I call it the main one. Typically, your project level stuff will happen here, and then you'll take certain parts of complexity, and you won't pile them all into this file. Certain things you'll push down into other build files, and that's what we've done. So as we go through this, we'll have to take a detour to look at those. When you use the Bazel TypeScript rules, those TypeScript rules need to be provided a TS config. It's idiomatic to attempt as much as possible to have just a single TS config, so I've placed that here, and I've used this export mechanism to make it so that other build files anywhere in the project can use these TS configs. That turns out to also be true of the package.json file. There's a couple of rules at least one rule that needs access to that, so I've also chosen to expose that. So this export mechanism makes these 3 files available as targets, and it makes them publicly available so that any other Bazel build machinery anywhere in this project can see these files. This is an interesting bit of complexity, but it depends on this thing called //src. So let's go take a look at that first. Okay, src, this is where the source code for MobX resides. Now, it is a TypeScript program, and by the way, if anyone notices this file, I'll return to this file later. This is a TypeScript program, so we're going to build it using the Bazel TypeScript TS library rule. Now, this TS library rule might not be perfectly well suited to the job at hand. At the moment, TS library sort of encodes how things are done at Google, apparently. And they just have a set of practices that have worked well for a bunch of projects there. But one of those is that for whatever reason, or I know the reasons, but I don't want to spend an extra 20 minutes here. What they consider their development mode gets ES5 files, and what they consider their production mode gets ES6 files. You could easily argue that in late 2019, as I record this, for production mode, they really should be bringing in like ES 2018, or I guess ES7 maybe, but that's just not what's done yet. Also, we're going to end up misusing some of this ES5 output as part of our production build, and that's okay because some of the excess stuff that'll be in there will get pulled back out by Terser. But anyway, at the moment there's this entangling between what's development and what's production versus what's ES5 and ES6, and maybe in some future TS library those ideas might be teased apart a little more. But that's why you see this kind of oddity of why is it talking about ES5 and dev mode. This is just connecting you back to, as of right now, as I record this at the end of 2019, this is what TS library considers these things. Okay, so TS library. So this is a rule that will output the result of TypeScript compiling some stuff. So here's how you tell it what files to go compile. This is the glob syntax to get everything from here on down in the project. So that'll get these top level files as well as a whole bunch more files that are in here. There are bits of code in here that reference the Node API, and so we need to allow that dependency. And there are bits in here that, or not bits in here, TypeScript is going to compile this in a way that, it needs that TSLib, which is sort of it's that mechanism for factoring out common code so that TypeScript does not have to admit as much repetitive code when compiling a bunch of files. That's called TSLib, and so that needs to be available to TS library as it compiles. This syntax right here, so at npm // and then something like this, if I wanted to, I could actually do something like this, and that would mean the whole contents of the node modules directory. Here's an interesting bit. In the JavaScript world, this is essentially universal. Every build step, everything you do in JavaScript automatically, or in Node, automatically has full access to read and use any code anywhere in Node modules. That's sort of intentional. But in the Bazel world, it's really all about incrementality. And if your rule is that all of the source code can depend on all of the libraries, then if any library ever changes, you have to rebuild all of the source code. Well, if all of the source code is 50 files or whatever, so what? But if all of the source code is 1 million files, then that would be really bad. So in Bazel, this is workable. You can do this, but it is bad form. If your project is small enough that this is a good idea, it may not be big enough to really be working with Bazel yet, at least in 2019. So instead, with Bazel, you get this syntax, and maybe in some more detailed training I could go over exactly what the syntax means. But with this syntax, you're saying, out of everything that's available in my node modules via my package JSON and yarn lock, whatever, grab this subset, just these two subtrees of that, and make them available for TS library to compile against. Okay, so we have a thing called a target called source, and that's in a directory called source. So if we just say //src //source in Bazel, that label, so if I say, oops, so //src / so this would be the this would say within my workspace, find a directory called source, which is a Bazel module. It has a Bazel build file in it, and find a thing in it called, or find a target in it called source, but you can do that as a shortcut. So it's very, very common for sort of the primary target in a given build file to have the same name as the directory that build file is in, and that's what you're seeing here. And then, for various reasons, TS library, its default output is the DTS files. So just sort of the public API of that code. And then there is this machinery here, this mechanism to go grab a reference to get a handle on the other two alternate outputs. So TS library has a main output of the DTS files, then it has a couple of alternate outputs for the actual compiled code. And there's various machinery in there to, to actually execute TypeScript in an efficient way if it needs to do both, that sort of thing, without reloading everything from scratch. Okay, so now that we have this context, so we know about that target, or that target with that label, this target and this target. Now we can understand what's going on here. So one of the more surprising things when first adopting Bazel is that I kind of assume you're really super familiar with Python. And that's because at Google, from where this emerged, at least from the early days of Google, a whole lot of important code was written in Python. And so it was and is reasonable to assume if you meet a developer who works at Google, they're probably pretty familiar with Python because they probably stumble into it and everything, all the time, even if the project they're working on is not Python. So you could sort of think of Python as almost like a lingua franca of inside Google. And therefore, this Starlark language, which is kind of a syntactic and semantic subset of Python, you could think of it that way, it has inherited some Python constructs. One of those constructs is this thing here with the brackets. This is called a list comprehension. So this is it's sort of like a way of defining a list and then calling a map on it. So here is a list. It's a list of strings. And then I'm going to map over that. And basically, I'm going to run this rule once for each of these. So what this actually means is make me an array of the output of calling rollup bundle once for each of these values for format. Now the output's actually discarded because the output of these things doesn't matter. We're calling these functions to define targets, to use a rule to define a target. But still, this has that sort of somewhat imperative effect of invoking this rule 3 times to make 3 targets because there's 3 entries in this list or array down here. Now, format, this becomes the looping variable over this loop. And so, this is a really fun line of code. The format on the right is this format, but the format on the left is a named parameter to rollup bundle. Named parameters is not a common language feature, but it is a Python language feature, and it is therefore a Starlark language feature. So that's what this line means. It means that this looping variable format becomes the value of the format parameter when invoking the rollup bundle rule to create a target. And then when we create the target, we're actually parameterizing the name of the target. This here is the list interpolation operator, sort of like a printf from C, if anyone's ever used that. But it basically means that the value of format will be stuck right in there. So that means you can sort of, if you've read these a bunch before, you just instantly read this as, I'm defining 3 targets named MobX.cjs, MobX.esm, and MobX.umd. And the only difference between those is the value of the format parameter when using that rule. So this gets me 3 targets. Now, When this grabbed the 3 targets, it explicitly asked for the ES5 source. And then, but some of my desired build output, again, echoing back to what the old Build.js script did. So some of that build output wants ES6 output. And for that one, I have to go ask for a different output from that TS library. And so I have looped to call rollup bundle 3 times to make 3 targets. And then I've just manually called it one more time to get a 4th target. And you'll see there's a lot of other commonality here. The config file is the same. The entry point is the same. The format, this format, you can sort of imagine putting in that list and like doing an if statement around this. Arguably, I might be like 2 or 3 lines of code shorter if I had added more complexity inside this list comprehension, but it seemed better in terms of being able to explain this code to go ahead and call this one separately. Okay, a few more bits. So when you specify the entry points, this is a rollup entry point. If you're familiar with rollup, you know that when you roll up code, you have to give it a path within the kind of body of JavaScript code you've given it of where the JavaScript entry point is. And you might look at this and say, well, that's weird. That's a TS file. That's because there's machinery in the Bazel rules Node.js rollup bundle rule that uses the TypeScript output to translate from this source directory to the destination JavaScript file behind the scenes. And that's really nice. That means that as the user of Rollup Bundle, I can just point to like my source code level entry point and not, let it worry about figuring out where in the file system that entry point ended up after the compilation. And then the same idea applies down here. Lastly, if we look in this rollup config file, so in the rollup config, this is basically bits that were borrowed from that old build script, and they use several plugins, but the 2 that were really necessary are the node resolve and the replace plugin. The details don't matter. This is just how rollup works. But importantly, when I call rollup bundle, it does not magically or automatically get access to all of the node modules, right? This is that Bazel idea of controlling your inputs. So we have to give access to the specific subset of all of our NPM dependencies that we want this rule to have access to as it runs. Okay, now this to this point, line 46, now we've only rolled up the code, I guess 4 different ways now. When I showed the build.js, the old way, the kind of MobX master mainline way of doing this build, they configured rollup to call Terser, which is a minifier, as part of the rollup process. And that actually would work here because I think most likely whenever I redo a rollup, that probably exactly matches when I have to redo the Terser, but it's definitely more idiomatic in Bazel world to split those apart so that in theory, at least, and in reality in a larger project, the more you break the separate tool invocations apart, the more Bazel can divvy out the work to a distributed array of build worker machines, and the more it can skip work. So right, if it redid the rollup because it thought something might have changed, and then the output had the same secure hash as it did last time, it would skip re-tersering it. So, I did not mean to do that. Okay. The key point though is that we want a total of 6 build outputs to match what the old build made, and 2 of those were simply minified versions of 2 of the others. And so I've just done that here. I've just defined the 2 outputs. There's some interesting bits here. So like when you call Terser and you give that rule a name, you give it a name without the JS on the end, but it actually produces a file with the JS on the end that you can ask for. So that's a bit of an oddity. So you notice these names are both without the JS extension, which is fine. It just happens automatically. MobX has some flow types. It looked to me like that was a piece of work in progress and that they weren't actually tested yet. But since the existing file was copied into the NPM package output, it seemed responsible to do the same in our recreation of that build. And so we used the copy file to do that. Copy file, oddly enough, that's actually not a built-in Bazel feature. That's part of that skylib. So you can just, there it is. For anyone that finds that irritating, that I had to go, import that rule and then, call it this way, I invite you to go read the Stack Overflow page on how to copy a single file in Maven. And it's something like 27 lines of XML to copy file A to file B. So this is not bad if you've been traumatized by that experience. Okay, so at this point, excuse me, we've compiled the TypeScript code. We've rolled it up 4 different ways in different package formats. We've minified 2 of those. Now we want to bring all that together to make an actual NPM package. The rule for that, as of a few days ago, is pkg npm. I want my package to be called MobX. And then you just tell this thing what's going to go in. Now, I think this is really a huge improvement over kind of the default command line thing that you get with NPM. With NPM package, you have to look at the npm ignore file or maybe the files key in the package JSON. And there's this sort of, there's a lot of complexity and scatteredness in how the system decides what files will go in the package. I like this rule because I simply tell it what goes in the package. I tell it these 2 files go in exactly as they are, and then go grab these dependencies, and these are all Bazel targets. Now, some of them, like this one, it'll be a target that produces a file of exactly this name. This one, it'll be a file that it produces a target of this name, or this target results in a file of this name with the JS on the end. So there's a little bit of naming things going on, but roughly speaking, so here are the 6 things we were looking for. And I could follow each of these up this file, and I could figure out where they came from. For the sake of helping me translate between the old build and new, I had annotated these with where this file landed in the old build machinery. But these are the key 6 files. This gets you the flow file. And then this brings along the TypeScript types. And there's a little wrinkle with that we'll see when I look at the build output in a minute. Okay, so so this point gets us to having an NPM package. Now, let me see if I can get a big enough there we go. So I'm going to go ahead and just verify this still builds, which I assume it will, since I just recently got it all tested here. Okay, so this will go actually perform the build, and it'll produce that output. I'm going to go take a look at that output before we go too much farther. So that output is going to land in a directory called Bazel bin, and then it'll be landed in here in a directory that matches the directory structure of the project. So at the kind of root of the project, there will be a MobX. Here we go. A MobX directory. And that MobX directory will contain the build outputs. Let's see if we can spot that. There we go. So this MobX right here I just clicked on. This is the actual generated package. So it contains the package JSON, 6 files, and then the source that has the types. Now this is where I said there is a rough edge. There's a lot of rough edges around at the moment. This is all, like I said, this just reached 1.0 3 days ago. But it appears to be a bit out of spec, or maybe I'm just somehow holding it wrong, but for some reason we're bringing along the JS files here, or we're bringing along the JS files as part of this source, and I believe these should not be here per the way it's described as working, but I've left that as an open issue. I've not tried to hack around that here. I've just left that as a point for future discussion. So there are some extra files in this MobX directory, but modulo those extra files, this MobX directory, this will be the output. This will be the NPM package ready to consume. Now, how do I know this is any good? Well, we'll see that in a minute. We're going to actually test it, but we'll pick up where we left off. Okay, so for reasons that will become clear later, we need to go make basically a copy of this MobX build output using the file group rule, and I've named it untainted as a hint why. Basically, this rule will have something called a Bazel aspect come along with it that will make it possible to determine what copy of node modules was used to build this. But I intentionally want to go test this with a totally separate node modules installation, totally isolated from the environment where I built it. And so to do that today, the workaround is you use file group to go make a sort of untainted copy, so to speak, available of that. And we'll see what happens there. If I look around, I could figure out where that landed. It's probably an out or something. Could probably poke around here and somewhere find that untainted one, but I guess I don't want to get distracted there. Okay, so I wanted to, lastly, the last top level thing that the old build did is it checked the flow types. I don't think this actually does anything, because I think if you go look in the flow types, or not there, if you go look where it's test flow star, I believe it's not actually doing anything yet. This fixed this name, I think, makes it not count as a JS file and therefore not actually test anything, because I couldn't get the flow types to fail either with my original or their original, or with this this changed way of running it via Bazel. It seemed like it never failed. Okay, so if you just remember this hook, so this MobX untainted, this is a copy or a way of accessing the NPM package output that we've created so far, and now I'm going to go consume that elsewhere. So where am I going to consume that? I'm going to consume that from tests. Actually, you know what? There's two kinds of tests. Let's start with the simple of kinds of tests first. The first kind of test is in this test base directory. These are Jest tests. And if I go look at there's another build file in here. I put the Bazel machinery for running the tests in a build file in the test directory. But, the important thing is that I am going to compile the tests that are written in JavaScript, or written in TypeScript, excuse me, of which I believe there's just one. And then I'm going to get the ES5 output from that, and I'm going to include that along with just the plain JavaScript when I call Jest. So this is a rule. This Jest test rule is actually shipped right now as an example of how to call a sort of off-the-shelf JavaScript tool from Bazel. So this rule I'm calling is actually considered example code. It's not considered like a shipped proven artifact yet. Nonetheless, it works fine. I've been using it. So this is how we run Jest tests. We give this target a name. If I go here and I type Bazel test ... means everything. At some point, yeah, you'll see this name. So there we go. And that passed. Small means expect it to not take more than some number of seconds. I forget the threshold. Sources are the files containing tests. So these are the ones that Jest should try to find a test in and run. That consists of just grabbing the JavaScript, which is sitting in there, and also of grabbing JavaScript, which is compiled from TypeScript. And this is basically a copy of the same, or an echo of the same machinery that we already saw explaining how to build TypeScript. You have to tell Jest where its configuration is. You have to tell it what it's allowed to depend on. Now, dependencies are files that Jest will need to access to run. So that's different than source files. So, test source files are files that have tests in them. Dependencies are other files Jest will have to access, and that's quite a substantial list. So, for example, everything in this util directory and all these folders are unchanged from the original, by the way. So everything in this utils directory, these are just extra files that are used to run the tests. And so to compile or to execute these tests, you'll need access to those. Jest works on the basis of comparing previous output to a snapshot. And so it needs access to where the snapshots are stored. It needs access. This is that /src. It needs access to the code under test. So this file right here lets the Jest tests see the ES5 compiled output of running the TypeScript compiler on MobX. So this right here is the only connection between the compiling the code and then running it. Now, the reason this grabs it at the point of that src ES5 is that these are unit tests. In a moment, we'll see some other tests which use the NPM, the NPM package build output, but unit tests just generally run against the file-by-file compilation. this Jest configuration uses Bazel to provide some extra JavaScript language capabilities. And so when it runs, it will need access to a bunch of Bazel things. Let me see. If you just look at the Jest config, this is a standard Jest config, nothing too special about it. But that's why it needs access to those things. And then the test code actually uses a thing called iterall and a thing called serializer, and I guess also conditional. Then the TypeScript tests use conditional type checks and tslib. So basically, this ends up being a list of all the dependencies that are needed to run this set of unit tests. Now, at some point, I could just reach a point of frustration and replace all of those lines with one line that says, I give up. You can look at all of the node modules. And in a small project, that would be a good idea. But in a large project, where you, again, have a sprawling, huge list of node modules, you really don't want to allow hardly anything to depend on all the node modules, because that would mean anytime any node module changes in any way, the whole world has to be rebuilt, which you don't want to do in a very large, sprawling project. Lastly, the Bazel that's run from within the Jest config needs an RC file, so we need access to that. And then one of these tools, I think, I'm not quite sure, I just don't remember if it was Jest or Bazel, wants to look at your package.json, so we had to give it access to see that. Okay, so the upshot of all of that is this line of successfully running the tests. And they say cache because I've run this repeatedly, but I could easily do a clean that would throw away at least that layer of the cache. And then if I do a Bazel test, it'll go and do a bunch of work. It'll rerun those, and it'll give more realistic times. Okay, so I've been holding off on the most interesting part, and that is, well, it's pretty easy to imagine, compile the TypeScript code and have the unit tests work, because that only had like that just had one or a couple of rules here needed for that. But imagine I had made some kind of mistake, because I'm the contributor for this last little bit of doing the NPM package bit. So imagine that I made a mistake on this NPM package NPM part, right? Imagine I screwed this up. Easy to imagine. How would anyone know? Well, the answer should be some kind of test. And the way that was done in the original code, here I just want to verify, I did not do the right kind of invocation to throw away the right kind of cache. Sorry about that. Okay, so the way this had been done in the original code, so let's go back there. I made a couple of edits. I'm just going to roll all these back. Okay. So, in the code from before, the upstream master of MobX, there is a very interesting type of test here. Let me try to get the source to it. They call these Webpack regression tests. Now, these are kind of ingenious. I did not look back to see who wrote these. Whoever wrote these was very clever. So, they wrote a program that imperatively, I don't want to walk through all the details, but it takes several combinations of Webpack versions and module formats, and then it makes a temporary directory named to match those, and then it takes these strings and it basically creates a whole project, 3 or 4 files, and then having done so, it installs the right version of Webpack, it executes Webpack, then it executes the bundle that Webpack produced, and it verifies the output as what it expected. So this is basically an end-to-end test where it's creating, imperatively creating 3 projects using Webpack to bundle code from the MobX package JSON. So we were inspired by what they did here, but definitely did not want to take this completely imperative approach in Bazel. That would be it'd be a very, very un-Bazel thing to do, to try to recreate this imperative promise chaining way of doing this in Bazel. So let's look at what we came up with Bazel. So what we came up with was to essentially more statically set out these examples, these workspaces. So there's a directory called Webpack tests. Now we need, to reproduce the same kind of difficulty as the old build had, we wanted to use 2 different versions of Webpack. So we made a couple of directories, one called v3 and one called v4. Each of these has a package.json and a yarn lock, and that package.json just points to a very wide version range of Webpack. For odd reasons, you need Webpack CLI version 3 dot something to work with Webpack version 4 dot something. It's just an oddity of the Webpack world. Okay, so these two directories, v3 and v4, these essentially serve as sort of a sandbox NPM package places for that to live. So by having these versions sitting in these package JSON files statically, we don't need to have that imperative bit of code we saw in the upstream master Webpack tests. That it's just sitting here today. I think this is a more idiomatic way to express, hey, we have some tests and they depend on Webpack version 3 dot something. Normally you would use a yarn lock or a package lock to lock in an exact version. But I looked at the old code for this, the upstream MobX master code, intentionally runs on the current version of Webpack, version x.y, as of when you run the tests. And although, you could probably make an argument why that's a bad idea, I looked around to find a way to reproduce that. And I had to go find this one. There was someone talking about it on Stack Overflow. If you don't have a yarn lock, this thing gets angry at you because when you do your build or when you do your workspace, we had to specify the yarn lock. And this is not optional. There's no way to say don't use a yarn lock. But if you just make a yarn lock and you just delete all but those first couple of lines, it works. So this is an intentional bit of non-hermeticity introduced into a Bazel build, because when I run this build, it will get the current version of Webpack 3 as of when this is executed, not as of when some files were checked in, and the same thing here for Webpack 4. So this v3 and v4 directory, you think of these as being, that's the right word, just sandboxes to run, to build a project with Webpack and a couple of things in it. Okay, and then these build files, these don't have anything in them. The purpose of this build file is to make this directory be a workspace, or to be a Bazel module so that you can refer to files in it when you need to. Okay, so here's our first Webpack test. The original test did 3 different variations. We decided to do a few more variations just because, once we have the pattern worked out, why not? So this is a test that uses Webpack 3.x and common JS modules. So it needs a source file that fetches or loads MobX in a way that will be compatible with loading it as a common JS module. And then, just a moment here. It didn't seem necessary to recreate the complexity of running the program, capturing the standard out, and comparing its results. It seemed easier to actually write this index.js to act as a test. So this essentially acts as a command line test in which the process exit value will reflect whether MobX worked correctly. So if MobX is working correctly, you can import it with require, you can grab the observable and auto run identifiers from it, you can make a MobX observable, you can tell it to auto run. So auto run means call this whenever anything that I depend on in it changes. So anytime store count changes, this will be run, and then I'll just append that onto this counts array. And so if I increment count and decrement count, I should get the original value of the store, because this function will be called the first time, when this auto, execution proceeds through and runs this line. And then when store count goes up by 1, this code should run again. And when it goes back down by 1, this code should run again. So I wrote this, you can sort of think of this as a equivalent of an expect. It's a one-liner. I wrote this line. So we just take those, whatever values got pushed on there, and join them, and then check the string. And we do this comparison in such a way that if everything is okay, it'll be a successful, a 0-ish exit code. And if this doesn't match, it'll end up being a non-zero exit code. So it took a little playing back and forth to get this inequality right. So, okay. So the upshot is, if I bundle this program and then I run it with Webpack, if it returns, if I bundle this with Webpack, then I run the resulting JavaScript as a node program, it will return 0 if the test passed. So let's see how we achieve that. So to build with Webpack, we normally need a Webpack config. So this is our starting point, very, very simple Webpack config. We need a file name for the output. We need to tell it what the right word here. Tell it which field to use when it's consuming a package JSON file. And this is a way of forcing it to use the common JS code. Then we need to target this code for nodes so that, for example, process works. Okay, so let's see, how do we build that in Bazel? Okay, so there are rules in this rules node.js for running arbitrary code. Okay, so one of the ways of running arbitrary code is what they call NPM Package bin, and it can do a bunch of things, but one of the things it can do is it can just grab some JavaScript binary, some JavaScript executable, something that came in via that whole package JSON mechanism, and it can run it. So parsing this back apart, that means go look and find out what this is in the workspace. So if I look in the workspace, this is the package JSON and associated files, node modules that came in from that v3 sandbox that we saw a few minutes ago. So this says, go use, let me see here. Go use that Webpack v3 sandbox, get the Webpack package, and then get a binary that provides, command line executable that provides called Webpack. And then we need to configure it appropriately. So outs. This defines the name of the output file that Bazel should look for and use as the sort of output of this rule. So we're sort of saying, Bazel, please trust me. We're going to call Webpack, and it's going to make a file called Bundle.js, and that's the output. Now, this is a mechanism of passing a bunch of arguments to Webpack, and then data, this makes files available for that Webpack execution to see. So let's we'll look at these in that order. So of course it's going to need that index.js file, right? Because that's the file we want to bundle with Webpack, that index.js. And then of course it needs the Webpack config, because Webpack, you always start by configuring it with a Webpack config. And then we really want to compile this against that MobX NPM package we built, right? Because this is supposed to be sort of an end-to-end or integration style test that will verify that the result really did work, that it can be compiled and it runs. So that's why we need access to that bit. Everything up to that point was easy. This is where it got really, really difficult. So this part right here is like the trickiest part of the whole thing. But for Webpack 3, here are the arguments that had to be passed. First, we had to put it in development mode, because you have to tell it development or production mode or else it complains at you. Next, we need to tell it about its Webpack config. Now, the way Bazel executes command line tools, it does not merely execute them like in the directory where that source file is sitting, right? This does not run things in this directory. It goes and it makes a sort of symlink-based sandbox and runs it over there. And then it tells you where you can find the files you depend on. So here's a file I depended on. Here is the syntax in Bazel for saying the path from the point of view of where this program is being executed in that sandbox to where that file is located. So I couldn't merely let it find Webpack config by default because it wouldn't be there. It would not be where it looked. I had to tell it where to find the config file. Next, I had to tell it an entry file, right? So this is sort of like that rollup entry file idea. You got to tell Webpack, here's the file you start bundling from. Well, same thing. I can't just say index.js because I don't know where that's going to be. I mean, Bazel is going to make this sort of symlinky sandbox, and it's going to put that file somewhere, and this is the mechanism by which it tells me where it put the file. So here I got to tell Webpack, there's where you found the file. So something you're probably already noticing, I configured Webpack partly using a Webpack config.js for all the static stuff, but the dynamic stuff where I had paths I had to get from Bazel, I did that configuration with the Webpack command line. Next, I got to tell Webpack where to write the files. Well, we've already told Bazel Webpack's going to write a file called bundle, and we've already told Webpack to write a file called bundle. The question is, where is it going to be written? Well, as part of that sandbox mechanism, Bazel will tell your rule, here is where the file should be written. And that is the syntax for how Bazel tells your rule where its files should be written. So I'm telling Webpack, your output should go where Bazel told me your output should go. And then lastly, if I left these two lines off down here, I would get an error because I would try to import or require MobX and it wouldn't be there. So this is a way, and there's something you can do in Webpack config. But this is the way where you can tell Webpack where to go resolve a certain identifier. So I can say, oh, that MobX, if anybody requires that, here's where you should go look. And this should be, again, Bazel is going to tell us where it put those files, right? So we said we depend on the files. Now this is how we ask Bazel, where did you put those files that we said we depend on? And here's the really frustrating thing. This bit required simply experimentation and study of what was going on behind the scenes. That's why I said, like, all of this was the trickiest part to get work, and of that, this was the trickiest part to get work, to get to work. I think the ideal solution would be to go write a Webpack rule for Bazel. So if you are going to use Webpack and Bazel together substantially, instead of this code being in an application, there should be a Webpack rule that understands this bit. So that definitely a rough edge or a piece of unfinished business for Bazel plus Webpack use. But after a little thinking, this was found to be the actual path to get to that code. The whole thing works. So the output of this will be a bundle.js file that is a result of taking this index and compiling it against the NPM package output that we created for MobX in this new Bazel-y way. Okay, so now we have a program. Well, Node.js test, this is a rule that takes just an arbitrary thing you can run with Node, say a JavaScript file, and runs it. And if it outputs a 0 exit code, that's considered a test pass, and a non-zero is considered a test failure. So since this is crafted to process exit with a 0 if all is well, it's just a matter of calling it. So bundle it, tricky, call it, trivial. Okay, so that's Webpack 3 with CommonJS. All the rest of these are approximately the same, but slightly different. So like this configuration is slightly different. You say mode development here instead of on the command line, because Webpack 4 is different from Webpack 3. In the build file, there's a couple of differences. So you don't have the -dev up there, for example. So I'm going to avoid going through all of these build files in detail because I'm already at an hour here, but suffice it to say they are slightly different in irritating ways. It would be very idiomatic as a Bazel user to write a Bazel macro. Like if you weren't going to go to the effort of writing a full-fledged Webpack rule, you would at least write a Bazel macro that would boil out the close but not exact, like the near duplication between these different files, the fact that they're almost the same but not quite, that could be taken care of with a Bazel macro, but that would make it even more difficult to dig in and explain and work from this as an example, if anyone needs to, of calling Webpack from Bazel. So I chose not to do that. Okay, so I think that is everything. So there's now this Bazel way to build the TypeScript code, run the flow types on it, although it doesn't seem to actually do anything yet, run the Jest tests, including some JavaScript and some TypeScript-based Jest tests, and then run 5 different combinations of Webpack features to take the NPM package output and verify you could actually consume it and have it work. So I guess that concludes our tour. I guess I'll go back here and thanks again to, it's not just me, other people both wrote code and reviewed code on this. And if anyone needs help with Bazel out there, you are certainly welcome to call us. Here's the way to reach us. So thanks for watching to anyone who got this far. Bye-bye.